Welcome to the best part of the year, the Qualitative Analysis Lab. Now, as you watch this video, I'm going to recommend you have your lab in front of you because I'm going to go over the information in your lab as well as that pre-lab that you have due Tuesday because I'm going to be able to answer some of the questions on that pre-lab or help you out with that. Now, this lab is called the Qualitative Analysis Lab because the purpose of this lab is to identify various ions based off their property. Not any sort of calculations or number crunching. You won't see any balances out in this lab. You are strictly trying to identify based off the properties. And there's two parts to this lab. The first part, you will get a known solution, and it has 9 different cations in it. And this is the quiz grade portion of this lab, and you will have to isolate and identify all 9 ions. And you'll see in your lab procedure, you'll see things that say, confirms the presence of lead. At this point, you need to show your teacher that you have found lead. You'll walk up to them and say, this yellow precipitant confirms the presence of the lead ion, and you will get credit for finding lead, and you'll find all 9, and that's worth a quiz grade. The test grade portion, after you complete the quiz grade and you find all 9 ions, is you'll be given an unknown solution that has 4 of the 9 ions. And you're going to go through the entire lab again. But this time you're not going to show your teacher. You're going to take really good notes and you're going to decide which 4 ions you have. When you think you know, you will bring that information to your teacher. And if you are correct, that is a test grade. Now, when you're doing this lab, it's a long lab. This is a multi-day lab. So it's going to be very important that you keep good records. Don't think, oh yeah, I'll remember tomorrow that I was on step 4. Make sure that you're writing down where you're stopping every day so you know where to pick up and start. We also recommend you don't stop mid-step, that you complete a step before you stop because it can kind of skew your results if you don't do that. You're not going to want to rely on your partner either. You're going to want to make sure that you both understand what's going on every single day. On the first day, you're going to receive a test tube with a cup with 6 empty test tubes and 1 corked test tube that has the known solution in it. This is the solution that has all 9 in there. You're going to want to make sure you label your cup and that you put it in the correct bin. You're going to want to make sure those test tubes are clean, rinsed out with DI water so there's no contamination in that test tube to affect your result. Now that 1 test tube that has your known solution, it's going to have about 6 mils in there, but you only need 2 mils to do it. So we're giving you enough to run this lab 3 times. So if you have any trouble, you can always go start over with the new solution because you have enough to run it 3 times. However, if you need more solution, you use all 3 of those, it is going to cost you some points to get some more solution at the end of it. So make sure you don't do this entire experiment with all 6 mils. You're going to have a material list. You can see that's given to you in your lab. You're going to have a bunch of test reagents. If any of these bottles in this basket run out, you need to see your teacher to have them refilled. Do not steal them from another station. You're also going to have a DI water bottle squeezer like this. You are responsible for refilling that from the DI water coolers. And you're also going to have one of these dropper bottles that has DI water too, because at some point you're going to have drops of DI water, and it's much easier to add them with one of those little droppers than it is with the big bottle. But if any of these empty out, you need to talk to your teacher and have them refilled by your teacher. Some other miscellaneous information before I get into the actual general techniques for this lab is if you break a test tube, it's going to cost you and your partner 50 cents. So be gentle with our test tubes. They cost us money to replace, so you are going to pay for them. If you do break something, make sure you're putting it in the appropriate broken glassware container. Like I said earlier, if you need more solution, like you've done 3 trials and you still can't find lead, you're going to cost some points. Make sure you get your partner's contact information, because if you're not here one day or they're not here one day and you're like, wait, did we do step 4? A text can be sent or communication can happen that way. You're allowed to work 1 day without your partner. So if your partner's in WAP and they're taking the WAP test, the AP WAP test, then you can work without them 1 day, but only 1 day. So if someone's absent 3 days, you're going to be sitting and wasting some time. If you and your partner do have some issues, there are some options for divorce. So just talk to your teacher about those. You're also going to lose lab points if you don't clean up your station, return your cup to the box, or you're breaking any lab rules. Like we have to tell you to put your goggles on. At this point in the year, you should know to do that. Now, this is where I'm going to start with that lab under that general technique. So you can see keeping good records, I've already talked about it. I'm going to talk about again how you're going to have to write this lab up. But right now we're going to avoid contamination. So the idea is you're separating these ions. You don't want to mix your separated things up. So when you stir, you're going to want to make sure that you clean your stir rod every time using DI water. We recommend you wet a paper towel and you wipe that stir rod off after every use to make sure you're not contaminating different test tubes. Some steps are going to require you to heat your solutions in a hot water bath. Remember, you need to make sure that there's at least half full of water. There are water refill beakers near the sinks that you can refill them up with. Tap water is totally fine. You don't ever want it to get all the way down, but if it does, turn the hot plate off, let the glassware cool all the way down before you refill it with water. You don't ever want to add water to a hot, dry beaker. It will shatter the beaker. When you stir solutions with your stir rod, believe it or not, you are Superman strength. You can break through your test tubes. This is the #1 way kids break their test tubes. So just make sure that you are using caution when stirring and that you're not breaking those test tubes because they cost you 50 cents. You're also going to have to centrifuge in this lab. So I can't remember if you've used centrifuges before or not, but make sure you never put corks on your test tubes in the centrifuge, and you have to counterbalance it. So if you only have one test tube, first ask the groups around you, hey, anybody need to centrifuge? And if they do, make sure you put their test tube opposite of yours. So if you had 2 test tubes, they'd look like this, 4 test tubes like this, so on and so forth. If nobody else needs a centrifuge, you need to create a counterbalance. So take a clean test tube, fill it up with liquid to the same volume that your test tube has, and put it opposite. You're going to close the lid, you got to lock the lid, and then you just turn the centrifuge on, and when you're done, turn the centrifuge off, and it'll ding, just like an oven. After it's done, the centrifuge will continue to spin. You have to wait for it to completely stop before you open it up and take your test tubes out. You're going to want to try to stop it with your hand or slow it down. You're going to break the centrifuge. You're going to break your hand. So just be patient and let the centrifuge stop spinning on its own. Now, as you're doing this lab, you're going to see some vocabulary. One word you're going to see is precipitate. This is the solid that forms at the bottom. But another word you might see that you're not familiar with is supernatant. And this is the liquid above the precipitant. So after you centrifuge, you'll have liquid on top often and solid on bottom. And sometimes it's going to ask you to just dispose of the supernatant, like just dump it down the sink. But other times you're going to need to save it. So make sure you're reading carefully what you're supposed to do with that liquid on top, because that liquid on top might contain some important ions or it might contain nothing. So just make sure you're reading that very specifically. It's also going to ask you in this lab to wash precipitants. This isn't like washing your dishes. What you're going to do to wash it is you're going to add DI water, stir it, centrifuge, and then discard that excess waste. The reason we're washing it is to make sure we get all of the ions we don't want out before you move on to the next step. So you want to make sure that you're isolating the ion that you're looking for in that step. The lab's also going to ask you to check the pH. You're going to use pH paper for this. You're going to get that from your teacher. Remember, pH paper or litmus paper turns red with an acid and blue with a base. So if it's asking you to add acid till it becomes acidic, you want to add until the litmus paper turns red. You're just going to take that stir rod, dip it into the test tube, and then touch it to the litmus paper. And one piece of litmus paper can be used for 3 or 4 trials. So make sure you're not being wasteful of the litmus pH paper. At the end, you're going to cork any solution, at the end of each day, that is, you're going to cork any solution that, any test tube that still has solution in it. If there's just solid in the bottom, you're going to want to add a couple drops of DI water before you cork it, and then put everything back in the cup, and then store that cup in the appropriate bin. Another thing you're going to need to do is dispose of specific solutions in a waste container. So in the lab, it talks about 3 ions specifically: silver, mercury, and lead. We don't want these solids to go down the drain. They're just not good to put down the drain. So there'll be a waste system somewhere in your teacher's classroom. You need to make sure, especially those 3 ions, you are disposing in that waste, and try to get the solid into the filter paper. Let the liquid go through the filter paper, but we want to capture that solid so it doesn't go down the drain. A couple things to remember. You're going to do the entire procedure with your known, and you're going to find all 9 of those ions, show them to your teacher. That is your quiz grade. But then you will repeat it with your unknown. Don't expect the same results with your unknown because not all 9 ions are there. Only 4 of them are. So if the first time you got bright yellow to confirm the presence of lead, the second time you don't get it, think about what that could mean. Do you have that ion present? You will be given an unknown number with your unknown. You need to make sure you write that down so we know which unknown you have. Once again, you'll be given 6 mils. That's enough for 3 trials. You can run this lab 3 times with your unknown. Always clean those test tubes really good because you don't want any of the remnants of the other ions in them. And then you're not showing your teacher every step this time. So wait till the very end and then tell the teacher what 4 ions you guys found. Some other hints. You have a lab procedure and a flow chart. You are following the lab procedure. The flow chart is just a general guide so you kind of understand the big picture about what's happening in each step. So don't be trying to do this lab from the flow chart. It doesn't work like that because it's not all the details and all the stuff that you need to add or react or do. So make sure you're actually following the procedure when you're doing this lab, not the flow chart. The flow chart helps you know when you need to identify or keep things. Finally, there is a lab write-up in your lab notebook for this lab. There's 2 different ways you can do it. You can create a chart that looks like this, which in step 1, you would write what the procedure is, and then with your known, you'd write the results and what that means. And then you go back and you'd fill out these 2 columns when you did your unknown. So you can compare these results and be like, a white precipitant formed here. It didn't form here. What could that possibly mean? What conclusion can you draw? So this is one way you can do it. It's like the table form. So you would create this table, you'd fill in the first 2 columns with your known and the last 2 columns with your unknown. The other option for this lab write-up, and we don't care which way you want to do it, whichever way your brain makes sense, is you can recreate the flow chart. So copy that entire flow chart, both sides, into your lab notebook and take notes on the flow chart for your known. So like right here in step number 1, you could say, you had a white solid form and you separated that out over here and you could take notes like that. But then you have to create a whole another flow chart, a second flow chart for your unknown. And here you would write like no white solid and talk about what that means. So you would take notes directly on the flow chart about what happened in each step. So you can either do the table or the flow chart. That is the general lab video to kind of give you some basis for this lab. You do still need to read your lab procedure that we gave you. So especially those first 2 pages where it talks about techniques and what reagents you have and all that analysis in order to answer your pre-lab questions and be ready for this lab. So I just want a brief overview. You should be able to finish that pre-lab and come ready for the lab on Tuesday. And hopefully you guys enjoy this lab because it's a really fun, sometimes frustrating, but real science experiment that's pretty darn neat that we get to do.